In the previous lecture, we finished exploring how to process mouse input in our Unity games. In this lecture, we'll learn how to process keyboard input in our Unity games, so let's go do that now. We're starting with the code we had before, and we're going to convert it from using mouse input to using keyboard input. We'll start by taking a look at the Input Manager. So we'll go to Edit, Project Settings, and we have the Input Manager already selected, and we'll look at the axes, and I'll expand the horizontal axis and show you that the negative and positive buttons are left and right, and the Alt negative and Alt positive buttons are A and D, and our default vertical axis has down and up and S and W. So the standard control scheme using both the arrow keys and the WASD keys. So in our code, all our work happens in the update method, and we're not going to convert mouse position to world position, nor are we going to convert keyboard position to world position, because there's no such thing as the keyboard position. So the way we should think about this is that we're going to move the game object that this script is attached to based on keyboard input, but we're going to move it a certain amount based on that input. So we're going to push the game object around with the arrow keys or the WASD keys instead of making it follow a particular cursor on the screen. That means I'm going to delete all this and say move game object as appropriate. I'm also going to immediately save, transform position into position, because position is the local variable that I'll change based on user input. Now I know because I'm going to move the game object around based on keyboard input that I'm going to need a move amount. So I'm going to come up to the top of my class here and add movement support. And I'll make this a const, and I'll make it a float, and I'll call it move units per second. And let's just say 5. We're going to set this up so that the game object moves 5 Unity world units every second if the player is holding down a horizontal key or a vertical key. And I'll show you how it can move faster than that before we're done with this lecture. So back here in update, we should check if input get axis, and we'll check horizontal first. And this time I'm going to check not equal to 0. So remember when we were checking the input axis for a mouse input, the mouse button, we were just checking to see if it was greater than 0 because we only had a positive input mapped to our input axis, the change character input axis. Here we have both positive and negative keys mapped to the horizontal input axis. So if we don't get a 0, we know that we have input. We don't yet know if it's positive or negative, but we know we have input on the axis. If we do, I want to change my position. So I'll say position plus equal, and now I've just realized that I need this value again. So instead of calling the getAxis method again, I'm going to create a local variable here that I'll call horizontal input, and I'll set it equal to this. And now I'll check if horizontal input is not equal to 0. And now I can come down here and use horizontal input here. Because I have a horizontal input, I want to change position.x. And I'll start by taking horizontal input. We're going to be treating horizontal input as a sign. So if the negative key is pressed, the value of horizontal input will be -1 because we're using a keyboard. If the positive key is pressed, then the value of horizontal input will be +1. And I'll write this whole equation, and then we'll talk about why it works the way it does if I, in fact, say position.x plus equal here instead of equal. Now I want to take this horizontal input, and I'm going to take this suggestion times move units per second time dot delta time. And I'll drag this over here so we can read it more easily. So ignoring horizontal input for a moment, this is how many world units we want to move per second. And as we discovered when we were building timers, time.delta time tells us how many seconds it took the previous frame to execute. So let's say that's 0.1, which is a really slow frame rate. If it's 0.1, we're only running at 10 FPS. But this will then be 5 times 0.1, which is 0.5. So on this frame, I'll only move 0.5. And if it's 0.1 consistently, as we call update, it will take me 10 frames to move 5 units. I'll be moving 5 units per second. If in fact the frame rate varies, that's great. Sometimes I'll move a little further, sometimes I'll move a little less, but over the course of a second, I'll be pretty close to 5 world units. The reason this works great as a sign is because I am adding, but if I have negative input, then this expression will evaluate to a negative number, and I'll add a negative number, so I'll reduce x. X will be less than it was before I did this. And the same if horizontal input is a positive number, I'll actually add. So that's how we can use horizontal input as the sign for the direction we want to move. We certainly could write a more complicated if statement here that says if horizontal input is greater than 0, then we add some stuff. Else, if horizontal input is less than 0, then we subtract some stuff. But this is a cleaner way to do it. Vertical input works remarkably similarly, so I'll type that code and then we'll come back and look at it. I've added a vertical input variable to hold the results of calling getAxis on the vertical input axis. And then down here, I'm doing a very similar thing. If we have vertical input, then I change position Y based on the vertical input, move units per second, and time.delta time. Notice that this is not an else if. This is an if. And the reason this is an if is because the player may want to provide both horizontal and vertical input on the same frame. Players like to move diagonally. So we use an if here so that we can move diagonally. We can process both horizontal input and vertical input on the same frame. We build successfully, and when we run the game, you can't tell, I'm using the keyboard to move up and down. Now watch what happens when I move diagonally. You may not have been able to tell watching the video, but I'm actually moving faster if I move diagonally. This is actually a famous bug in Doom. It's called the Strafe 40 bug, because if you move diagonally, you can actually move at a faster speed. You're actually moving at 5 times square root of 2 on the diagonal. And that's because over the course of a second, we're moving 5 horizontally and 5 vertically. So if you imagine a right triangle with both of the legs being 5, the length of the diagonal is 5 square root of 2 because that's the Pythagorean theorem. So you can actually move faster diagonally than you can move either horizontally or vertically by themselves. And if I run the game again, you see that I move with the keyboard, but I change character by clicking the left mouse button. Let's convert the change character to use the keyboard as well. We'll go back to the input manager, and I'll collapse the horizontal and vertical input axes and come down to our change character axis. Remember, we were using mouse 0 as our positive button, but I can just change that to space instead. And if I do that, When I run my game, you can't tell I'm clicking the left mouse button and nothing is happening. But if I press the space bar, I'm actually changing the character by pressing the space bar. We certainly could, of course, have had an Alt positive button as well, so we could have made it so mouse 0 changes the character and the space bar changes the character, either one. But I wanted to totally convert this to keyboard input, so that's what we've done. And the great thing about that change we just made is we didn't even have to touch the character changer script, because the character changer script just uses the named axis from the input manager. So we could change the input button for that input axis here in the editor, and we didn't even have to touch code to convert the changing character functionality from the mouse to the keyboard. To recap, in this lecture you learned how to process keyboard input in your Unity games using the input manager and named input axes, and you also saw that we didn't even need to change the script to change our action of changing the character, because we could just remap that input from mouse 0 to space in that input axis.